This is Ujjwal Kumar Sen, and today we are going to talk about welding. And yes, I'm not going to talk about any theoretical part here. This video is only dedicated for GATE and other competition examination. Just like so, basically, what I'm going to share with you in this video, I'm going to share with you a couple of numerical problems, those already asked in GATE. Okay, and of course, formulas you require to solve those problems. I have gone through more than 10 questions related to welding only, so definitely I'm going to share with you what formulas you require to solve the problems first, and second I'm going to share with you how to solve the questions those already asked in GATE, right? So let's go for it. So formula number one, that is H is equal to I square RT. Okay, now what is H? H is heat input. Okay, I is current, that is in ampere, and R is resistance, that is in ohm, and T is time. So by using these things, we usually take in seconds. So by using these things we can find out heat input, and this formula we generally studied in case of resistance welding. Okay, so this is all about the first formula. Now second formula, I must say, in one question they have related with density is equal to mass by volume. To find out volume they have relate this formula with the numerical problem. That's why I am sharing with you, although this is the most common formula and you must know about it. If you are preparing for competition examination, then I must not share with you these formulas. Maybe you are newbie, that's why I am sharing with you. Now we have another formula, that is actual heat input. Actual heat input. Okay, actual heat input is equal to Vi by velocity into area of weld bed. Okay, that may be an mm square or meter square, that will be depend on us. Okay, into efficiency of heat transfer. Efficiency of heat transfer. This is actual actual heat input. If I am talking about heat input, then just remove this one. I mean if I am talking about fourth number formula, heat input, then we can say that Vi by velocity into area of weld bed. So this is all about the formulas, right? Another formula is that is melting efficiency. Okay, so melting efficiency is related to this only. I mean, what is melting efficiency? Suppose that melting efficiency eta m. Okay, so this is equal to actual heat input. Actual heat input, actual heat input, its reciprocal multiple its heat required to melt material. So these are five formulas. These five formulas, if you remember well, this formula is they did not use this formula till now, as I have gone through question. They are in most of the question they are using this formula and this formula. So most important formulas are two only, formula number 3 and formula number 1. But definitely why I'm sharing with you these things, because at least you will have few formulas. So for this video, write down these formulas and try to remember and try to understand what is going on there. Then go for the next part of this video. In this part I am going to share with you a couple of questions. That's why you can do much better in the competition examination. Okay, so let's go for those questions, right? Yeah, so here is the question. I hope you can read the question. So in this question, what we have, in an arc welding process, the voltage and current are this. So just write down given. Okay, if you're beginner, voltage is, I think this marker is not working. Its ink has been finished, I think so I have to use the different one. So V is equal to 25 volt, I is equal to 300 ampere. That's it, respectively we have given, right? The arc heat transfer efficiency, that means heat transfer efficiency is equal to 0.85. welding speed is 8 mm per second. Okay, that means speed or velocity there I have used is 8 mm per second. Now what I have to find out? Net heat input. I have to find out net heat input. Okay, so what I can do to find out net heat input, that is also important. So how to find out net heat input? Okay, so we know that I have shared with you the formula. Let me share with you. Actual heat input is this multiple heat, right? That is heat efficiency or heat transfer. You may say that this is known as heat transfer efficiency. Okay, so let's go for it. So we know the formula for solving the question, right? So now what we have to do, we have to just put that formula. So what's about that formula? I hope you know about it, right? So we know that net heat input is given in joule per mm. Okay, now most important, the formula we know, that is actual heat input is equal to VIY velocity into weld wet area into efficiency, but its unit is in joule per mm cube, but we have to find out in joule per mm. Okay, so what we can do, we can send this area to this side, then what will happen, joule per mm cube into mm square, so this will become joule per mm. That means according to our requirement we got it. So it's joule per mm actual heat transfer input is equal to Vi by velocity into efficiency of heat transfer. Okay, now we know that efficiency of heat transfer is given 0.85. Okay, so what is the value of Vi? V is voltage, I is 300. Now velocity is 8. So all unit we have given here. Now what we require to solve the problem, that is calculator, right? So I have right now calculator. Okay, now divide by 8 multiple 85. So the answer is coming here, that is pretty sure, and the answer is absolutely right, that is here is equal to 796.875 joule per mm. Now I'll see the answer we have given in this option, which one is most accurate or most nearby, that is B. So the answer for this question is B. So the formula we have used here, that is actual heat transfer efficiency. Now we'll go for the next question. Hope you are enjoying the tutorial, right? So if you have any suggestion regarding the tutorial, then let me know. I will try to improve. I will try to help you more through my all videos. Okay, so we'll go for the next question, that is now I have already shared with you what to do. Okay, now I'm going to share with you how to solve questions in very fast way. First of all, you need to find out what you need to find out in the question. So for I have analyzes more than 2 to 300 numerical problems, those already asked in GATE. In those questions, what I found, more than 80% numerical problems they have asked what you need to find out at the end of the question or probably first line of the question. So here what we need to find out, if the unit melt energy is this, the time required for welding, we have to find out time, right? So we have one relation. I have shared with you couple of videos, right? Couple of questions, and in this question we have directly relation with time is this one. So we'll write that is only here, H is equal to I square RT. Okay, so now what I am going to do, I am just going to do this H by I square R. Now what we have, I have resistance I have, that is 42.4 ohm. Okay, voltage I have, that is 30 V. Okay, now I have diameter, that is diameter is 100 mm and thickness is okay, so its diameter, inner diameter and outer diameter is equal to 1110 mm. Joint, flash bed joint. Okay, supply at the interface. Okay, so its supply at the interface, that is thickness, is equal to 1 mm, means this will be 1 multiple 2 because its welding is going on. So the 1 mm both side. So total thickness would be 2 mm. A material melts from each 5, which as resistance is this, and energy. Yeah, we have given energy. Melt energy is 64.4 megajoule per millimeter cube. Okay, so this is all about the data we got. What formula I have to implement, I have shared with you. Okay, now what I can do one thing, one simple thing, that is here. So what I know basically, H is equal to I square RT. H is his heat input, that is also known as energy, but this energy should be in joule. Remember that. Here in welding, most important thing is that unit. You need to remember unit, what exactly is there, right? So here unit in joule, but we have given energy in megajoule per mm cube. So what is this per mm cube? That is weld. So I have to first, what I have to do, I have to find out its what I have to find out, can you guess, my dear? I have to find out its one thing, one most important thing, that is I have to find out its volume of that weld. So how I can find out that? It's pi by 4 d square into t. This is the volume. So pi by 4 d square, but this is, there inner side diameter and outer side diameter, so I have to do d naught minus di square into t, thickness. How much value thickness I have? Can you guess? That is important also. I have to know what is thickness, that is I have shared with you 2 mm. So 2. So what I can do, I can just write simply here the values. Pi by 4 d naught square is, that means outer diameter, 110, and 100 square multiple 2. This is the volume, right? So what I can do, pi by 4 is this, multiple 2 is this, multiple 110 square minus 100 square is equal to this much. So how much values basically we are getting here? It's volume, right? Now if I multiple this value with this, then I will get this energy. So I'll multiple this 64.4. So how much values getting right now? I am here 212434.4. Okay, now one thing is here, that is most important. What we are making mistake here with this, and probably with this and this. So what exactly mistake we are making, I'm just sharing with you. What mistake we are making basically, this is given in millimeter. Okay, this one is also given millimeter, but here we did not multiple this with here, that is mega. Mega means how much? 10 to the power 6. So we have to multiple that thing with this also to get the exact values what exactly we required, right? So by using that, by doing that, we can find out the real value of it. Okay, so what I can do, just I have to look at all unit first. So this is given in millimeter, this is given in millimeter. Now look at this unit, that is 64, I haven't shared, 64 megajoule per meter cube. So there by mistake I have written that millimeter cube, so I had to check all unit first. So what I can do here, I can do simply one thing, that is this is in millimeter. Okay, so how many units we are using in millimeter? 1 and 2, so 10 to the power minus 9, and this is in meter, but mega, that means 10 to the power 6. So 10 to the power minus 3 is remaining with me. So how much values I am getting after solving this? I have to multiple with 10 to the power minus 3. So what I can do, minus 100 square, okay, multiple pi by 4 multiple 2 multiple 64.4 multiple 10 to the power minus 3. That is how much values we are getting? 212.434 joule. So H is equal to, we got from here 212.434 joule. So 212.4344 we got here. Now we don't have value for I, we have given R. We know that V is equal to IR, Ohm's law. Okay, so what we can write, that is I is equal to V by R. So V square R square into R, so R cancelled, so 212.4344 into R by V square. So 212.4344, R is how much? 42.4, and V is here 30 square. So I can do multiple 42.4 divided by 30 square. So how much values I am getting? You can see here how much values I am getting. That is 10.00 second. So the answer from here is D. So actually we are making mistake, that is in unit. So don't make mistake there. Probably if you make mistake, then probably it will give you wrong answer. That's true, right? Now we have another question that is given and in front of you right now. You can read the question and by pausing the video, right? So in this question, what we have to find out: current passing through the electrodes. Current passing through the electrodes. So for finding out this, what we have the formula, that is H is equal to I square RT. So I is equal to H by RT root. So we need to find out H, we need to have R, and we need to have T. Once we'll have all these values, job done. We don't need to get tension, right? So this is the way to find out. Now what we have to do, we have to find out all values from here. All values from here. So first of all, let's go for it. That is, we have to get H. What is H? Now we'll read the question. Spot welding of 2 mm thick sheet metal. This one. Density is given how much? Density is 8000 kg per meter cube. Again, check unit. Okay. Is carried out successfully by passing certain amount of current for time is 0.1 second. How much time we have given? That is 0.1 second. So always see time also. Time play most important role here. Now we got time, we got density. Now the resultant weld nugget formed is this diameter. Diameter is this and this much thick. Okay, no problem. The latent heat of fusion is okay. We have given heat is equal to 1400 kilojoule per kg. 1400 kilojoule per kg, right? Now if anyhow I can convert this into kilojoule, then my job is done, because I need H. Now for getting H, what I have to do? 1400 kilojoule per kg multiple mass. Now I have density is equal to how much? Mass by volume. The mass is equal to density into volume. So I have to multiply with density and volume. So 1400 density is how much? 8000 into volume. So what is the volume? I have to find out from here. Now what is volume here? Basically pi by 4 d square. D is how much here? Diameter 5 square, and then thickness is 1.5. So I have to multiply with 1.5. Again, if I am doing this, I am making mistake because I am not checking unit. So this is in kilo, so I will multiply with 100. Again, all these three are in 3. How 3? How I am saying that this is 3? Because 5 mm, that means 5 mm square, 2 mm square. Okay, and then this one. So I have to multiply with 10 to the power minus 9 to get it right. Okay. Now what can I do? I can just use calculator, and probably in GATE you are not going to get this calculator. Not probably, you are not going to get, because you will get online calculator. So always have this in mind, that you will have this one only. So how much values exactly we are getting here? You can see 329.86 joule. Okay, 329.86 joule we are getting here. So this is how you can find out H. Just write down H is equal to 329.86. Now I have R, that is operation welding resistance is 200. Again unit 10 to the power minus 6, and time period is how much? 0.1 second. Okay, so this is how we got all values here. What right now I have to do? I have to just use calculator again. 329.86 329.86 divided 200 multiple 10 to the power minus 6 multiple 0.1. So we got these values. Now I have to find out its root. is how much we are getting? 4061.157. That is, it's ampere, right? So unit would be ampere. So which one is the right one? A. If this one not exactly, but yes, this is a close one. 4060 ampere. So this is the right answer for this question. I hope you understand the question, and probably it will help you a lot in examination, just like so. Now last question I have right now in front of you, and I'm sure this question is amazing. I have how many formulas I have shared with you. Based on those formulas you can solve each and every problem. Almost all problem you can solve. One or two problems you cannot solve maybe. Okay, so this is the question. So in this question what we have given, I mean, first of all, find out what you need to find out. Heat generated during the process, that means H is equal to what you need to find out. We know H is equal to I square RT. Now I need to get what is I, what is R, and what is T. If anyhow I can manage to get things done, I mean things done, you don't need to get tension. Okay, so how to get all these values? Read the question. So as you can see, it takes seconds. So 0.2 seconds. R is 200. Okay, unit 10 to the power minus 6. I have to multiple, this is in micro, and I is 5000. 5000 whole square. So what I have to do? I have to use calculator. So 5000 square multiple 0.2 multiple 10 to the power minus 6 or 6. Then and I have to multiple with 200. Then how much we are getting? 1000. So 1000 joules, Joules, joules is the right answer for this question, that is option D. So this is how you can solve question related to welding. I hope you enjoy the tutorial, and if you haven't noted down all formulas and try to understand things, and of course don't forget to understand its unit, because unit play most important role in case of gate. Otherwise you will get wrong answer. You know everything, but you are going to get wrong answer. I don't want that. That's why I'm sharing with you this thing again and again. I hope you understand the tutorial, and hopefully you can do much better in case of welding topic. Thanks for watching. See you soon in my next video. Bye bye.